transforming parent functions that we talked about. Our four functions were constant function, linear function, quadratic, and absolute value. And we're going to kind of be looking at the same thing today. What we're really going to focus on specifically today in 2.2 is transformation of linear and what? Absolute value functions, okay? Linear and absolute value functions is what we want to try and take a look at. So I'm going to read the question, and then I'm going to have you guys help me with the goals and the vocabulary when we read through this. But the essential question, follow me on this, okay? This is pretty important. I guess that maybe the first thing I should start with today is this. When we start seeing function form, in other words, something written like f of x, sometimes we say f of x is the same thing as a what, kids? F of x is really the same as y. Okay, it's like saying, instead of f of x equals, it's like saying y equals. So if you can think of f of x as like, ooh, that's kind of like the function y equals something right there, that's going to help you a lot. Okay. Question we want to try and answer today is the following. How do the graphs of y equal f of x plus k, y equal f of, in parentheses, x minus h, and y equal negative f of x compare to the graph of the, what's the word here we underline, kids? Okay, parent function. What we're really going to be looking at again is, hey, identify your parent function, number one. Tell me how it transformed. It's just going to be in a different form today. It's not going to be in the normal y equals form. It's now going to start appearing in function form. We just want to look at how this works today. Excuse me. I think one thing that you may want to do, you may want to have decimals open. I'm not going to tell you you have to, but you might want to have it open. Vocabulary is going to be very important. Before we hit that there, then, to answer those questions, how do those graphs transform from a parent function of f? What's our first goal up there today? How about a volunteer to read that for me this morning? Who wants that first goal today? Get after it on a Monday. Here we go. Who wants that first goal? Say it loud and say it proud, Jaden.
Write functions representing translations and reflections.
Okay, we know translations. That's just a slide, and a reflection is a flip. We know that stuff already, don't we? Okay, thank you, Jaden. Jaden, pick someone to read the second one.
Shy.
Thanks, Shy.
Write functions representing stretches and shrinks.
Stretches and shrinks. Vertical stretch. Vertical shrink. We're also going to look at some horizontal stretches and horizontal shrinking today. That'll be new. Gosh, what's going on here? Gosh, I feel like I blew a 20-point lead in the fourth quarter. All right. Last one then. Write functions representing combinations of transformations. Okay. All right, kids. You know I always kind of go in the same form with notes and stuff, and I think it's very important that we touch on vocabulary before we go through it. And what we really do is we end up kind of learning the vocabulary as we explore some of the problems we look at. I'm going to tell you today that vocabulary, this is pretty important. These are basically your rules today, all right? The vocabulary is pretty important. These are really going to be your rules to live by today, all right? Okay, I'm going to kind of group these together. All right? Horizontal translations, vertical translations. Have we talked about moving stuff left and right and up and down? We have, okay? So horizontal translation, first of all, we know that this is left and right. Okay, we know that this is either left or stuff is going to move right. Okay? All right, let me blow this up here quickly so we can see this a little better. For horizontal translations right up here, kids, it says the graph of y equals f of x minus h. Notice what they have right here again, kids. Parentheses. The h is the value that's really going to affect stuff right here. When I put this h in parentheses like that, that means it's either going to move left or right. There's a horizontal translation of the graph of y equals f of x where h cannot equal 0. Here's what I'm going to tell you. If you have minus h, it's going to move, anybody have a guess? It's kind of the opposite in parentheses. If you have minus some number, it's going to move right. Okay? What if you have plus h? It's going to move left. Okay, so you might want to get those in here. Guys, our vocabulary is really going to be like our rules with this function notation today. All right? This vocabulary is going to be like our rules for function notation. Okay, so the next one is vertical translations right here. They use this constant value of k right here, it says, oh, I didn't want to do that. I want to do this. This value k says the graph y equals f of x. Now we're adding some number k. Guys, is this k value in the parentheses or outside the parentheses? So when I'm adding or subtracting a value outside of parentheses, that's no longer a horizontal movement. It is a vertical movement. We discovered that in the last section. So what I'm going to write here, guys, is this. If you have plus some value k, if you have plus some value k, what direction is it moving? Up. And then what if it's minus some number? Down. Okay. All right. Okay, we've talked about stuff as it reflects with the x-axis. This is something that we know already. It'll show up in a different form. But this one right here, we didn't talk about reflecting in the y-axis the other day. So this is going to be a new one for you right here. That reflection in the y-axis is going to be new for you today. How about a volunteer to read our rule for reflection in the x-axis? Let me ask this question. Reflecting over the x-axis. Here's the x-axis. I take something and what was the word we used? If I go and reflect it over the x-axis. It does what?
Flips.
It flips over there. You guys remember what we were doing to our x values or our parent functions? What do we put out in front to make it flip? Negative sign, okay? So here's the deal. It says the graph y equals, where's that negative sign out? It's out in front of the function, isn't it? Right here. You guys agree with that? Okay. If that negative sign is out in front, then the graph of y equal negative f of x is a reflection of the x-axis. It's a reflection of this, okay? So what you might want to write down is this, is your negative is really just out in front of the function. All right, negative f of x. You see the opposite of f of x like that? It means it's a flip. Okay, now the one that's new for us, kids, again, it's going to flip, but now it's not going to flip over the x-axis anymore. It's going to flip over the y-axis. What's it say there, kids?
Y equals f of negative x.
Where do they put that negative sign this time?
In the parentheses.
Okay, the negative is in parentheses. So I'm going to write it this way. It's f of, this time the negative is inside of the parentheses. So that means this. If you put that negative inside parentheses like that, it's not flipping it from top to bottom. It's flipping it from left to right or right to left. Okay, so do you understand the difference between these two? The negative's out in front of the whole function. Okay? Here when you flip over the y-axis, you're only changing the sign of what, kids? This is saying change the whole function. This is saying just change the sign of x right here. And we'll look at some examples. So make sure that that's what you really need to know here. Okay? All right, horizontal stretches and shrinks. This is kind of a new one, and this is lengthy. All right, and this is an important one. I have a volunteer that would read that mess for me.
The graph of y equals f in parentheses ax is a horizontal stretch or shrink by a factor of 1 minus a of the graph of y equals f of x, where a is bigger than 0 and a is equal to, not equal to 1. Multiplying the inputs before evaluating the function stretches the graph horizontally away from the y-axis when 0, whatever that is.
0 is less than a is less than. Basically, it's saying a is between 0 and 1.
And shrinks the graph horizontally towards the y-axis when
Okay.
a is greater than 1.
Here's the deal. Horizontal stretch happens this way. As an example, I'll give you two examples. Suppose we have f of 3x right here. Okay? We don't have just the parent function f of x anymore. We have f of 3 times x. First of all, talk to me about this a value. Is this inside parentheses or outside of parentheses? Inside of parentheses. Okay? So here's the deal. Horizontal stretches are going to happen when you times inside of parentheses. Okay, and I should really change this here quickly. Let me do this. I should write it this way for you. I'm going to get rid of this part. This is going to happen when you actually, all right, it happens inside of parentheses. Okay, and you are timesing your parent function by a greater than 1. Okay. This is going to be a horizontal what's it say right here? Where a is greater than 0, a cannot equal 1. It says right here, multiplying the inputs by a before evaluating the function stretches the graph horizontally away from the y-axis when it's between 1, and it shrinks the graph when a is greater than 1. Okay, so let's see. Is this a value right here for f of 3x, is that more than 1 or less than 1? Okay, things that happen inside the parentheses are exactly opposite of what you think should happen. Putting a 3 out there, you would think, oh, it's going to stretch it, but it actually does what? Okay, so this is going to be a shrink. It's going to be like a compression. It's like you're from side to side and you're pushing it in. All right, so this is going to be a shrink, but not a vertical shrink, horizontal shrink. And then the next one. How about an example here? F of, say, 1/3 x. Is that a value between 0 and 1, or is it more than 1?
More.
It's more? No. It's 1/3.
Oh, between.
It's between 0 and 1, right? This is going to imply then a horizontal stretch. Okay? All right, then the last part here we've kind of talked about. Maybe I should write this down again. Horizontal stretches and horizontal shrinks will be new for us, and I think you'll get this here. But you got to understand all the multiplication is happening inside of parentheses. So we'll look at this here in a second. All right? Last one here then, kids. I'm just going to kind of go and tell you what the examples are. It reads very much the same as horizontal shrinks. The difference is something like this. Instead of happening inside of parentheses, you might have 3 times f of x as an example. And you might have 1/3 times f of x as an example. Kids, where are the 3 and the 1/3 at now? They're before the function. Okay? This is what happens when it's before the function. It's basically saying, this is like saying take f of x, take all your y values times 3. So that would be a vertical stretch. Okay? And 1/3 times f of x would be a shrink. So kids, horizontal stuff, a lot of horizontal work, either compressing or stretching left to right, or moving stuff left and moving stuff right, usually happens inside of what? Parentheses. Parentheses, parentheses, parentheses. You see parentheses and stuff happening inside of parentheses to your parent function that indicates some kind of horizontal change. Okay? All right, so again, the vocab is kind of your cheat sheet for what's about to happen here. Do you guys have any questions about the vocab first? Kind of confusing right now, I get it, but we'll start putting this stuff in action. I think this will make total sense when you see about what we can do with this. Questions at all, kiddos? Everybody have that down right now? Okay, let's roll. Page 2, kids. All right, let's get some of these examples figured out. I'm going to do one, and then you're going to do one. Okay? Again, we're talking about linear functions and absolute value functions. I'm not telling you to use decimals to solve stuff, but if you want to confirm some things you're thinking about with decimals to say, yeah, what I think matches what I graphed here, I'm certainly okay with that. All right, example 1 says writing translations of functions. What are we letting f of x equal here, kids? Okay, here's the situation. First of all, what kind of function is 4x minus 9? What parent function would model this? It's linear. Okay, that's in slope-intercept form, isn't it? Okay. F of x equals 4x minus 9. So this is linear. Okay. I'm going to do part A with you as a group, and then I'm going to see if you can't do part B's on your own here today. It says write a function g whose graph is a translation 5 units, what's the word? Up. Okay. 5 units up of the graph of f. If I want to take that line and translate it up 5 units, what do I have to do? What operation would I have to apply to get a transformation that would move a line up 5 units? Say again, Jaden?
Stretch.
Not quite a stretch. I want to move the whole thing. I just want to translate it. Slide it up. I'm telling you the movement. You don't want to stretch it at all, because I'm telling you I just want you to slide it up. I want to know what operation are you going to apply. Are you going to multiply this function, or are you going to add to this, or?
Add outside the parentheses.
Okay. Are you going to add inside or outside of parentheses, Annika?
Outside.
Outside. So here's the deal. G of x is going to equal that original function. What was the original function here, kids? 4x minus 9. And you say to move this up 5 units, I have to do what? Add 5. Okay. Well, let's simplify this to get a solution here. It looks like to me g of x will equal, any like terms I can combine in what I've written there?
Negative 9 and 5.
So this will be equal to what?
4, negative 4.
Careful. 4x, you mean minus 4?
Well, yeah.
Okay. 4x minus 4. I have a question, kids. And again, this is what I think decimals is important for. Oh, I'm still listening. What was the original function? 4x minus 9, was that right?
Yeah.
I'll type in 4x minus 9. Here's the original function. We think the new one now is 4x minus what?
4.
Guys, from this point right here to this point right here, how much changes are going from negative 9 up to negative 4? 5 units. Does that happen everywhere? Did this point move up 5 units? It sure did. Does it look like this point moved up 5 units right here?
Yeah.
Sure does. Okay. Translating up 5 units means add 5 without parentheses. Take your original function, throw a plus 5 in there, and then simplify. That's all we're doing. You guys try part B on your own. I want to see what you get. Part B is a little trickier. What direction are you moving, kids? Right, so are we going to have parentheses with that parent function x? Or not? Yes. So here's how this is going to work. Going 1 unit to the right, h of x becomes the following. It equals 4. That was the original. But instead of just putting x up there, we're going to put x. I want to go to the right 1 unit. So parenthesis x.
So you put the parentheses before, like,
Right around the x part, okay? Only the x part, all right?
I only put it around the negative 1.
Okay. I'm going right, so am I adding 1 or subtracting 1 in parentheses? Now keep in mind, guys, wasn't there a minus 9 up here as well?
Yeah.
Could that simplify further now? Could that simplify further? What would this look like then if I distribute? Wouldn't that be 4x minus 4 minus 9, which is equal to 4x minus 13? You guys agree with that? What direction did I want this to move?
Right.
Want to move right 1 unit. I'm going to go back into decimals. The original function was 4x minus 9. The new one now is 4x minus... Take a look here. Take a look right here. Let's do it on the x-axis here, actually. Take a look. Shoot. Yeah, we'll go with it. Did that go right 1 unit?
Yeah.
From 2.25 up to what?
3.25.
Okay. When we talk about inserting parentheses, it's only involving the x part. Okay. The only thing you're affecting is the x. Okay. All right. Let's move on this. How many had that, by the way? 4x minus 13. How many are okay with 4x minus 13? Again, I wanted to go what direction here, kids? Right 1. So instead of having 4 times x, to make this move right 1 unit, you have to put 4 times all of x minus 1 there. So I distribute 4 times x, 4 times negative 1, that's this part, still a minus 9 as part of your original function up here. So what we really did was replace this x up here with what? What did we replace it with?
Listen, where did you get minus 4?
When you distribute here, 4 times x, 4 times negative 1.
Oh.
Okay, got it? And then that minus 4 and minus 9 makes the minus 13 as part of our final solution. Good with that now? Okay. All right, let's try example 2 here. First of all, parent function for me, kids. F of x is this function right here. What's the parent?
Oh, in the absolute value.
Absolute value, yep. Parent
X
function.
minus 5, and then that ends and it's minus 4.
Okay, so it says write a function h whose graph is a reflection in what, kids? X-axis. Go back and look at your rule for reflection in the x-axis. Is it negative f of x or is it f of negative x?
It's negative f of x.
Okay, so what this is saying is this. To reflect in that x-axis, it's saying you need to negate all of f of x. So isn't f of x this whole function right here? Okay, so we're going to put a negative out in front of the parentheses. That's got to happen first. But if I'm negating this whole thing, this minus 4 is going to become a plus 4. There's really 2 parts. The absolute value, which is positive out here to begin with, right? It doesn't have a negative sign, so we're going to make this, h of x is going to become the following. It's going to become negative absolute value of x minus 5 first. And then it says negate the whole function. Minus 4 should become what then?
What'd you say?
The minus 4 would turn to a...
Plus 4.
Okay, let's check and see if this is right. Somebody read the original function for me. Absolute value... Oh, where are my absolute value bars at, kids? Functions. I don't want that. Where'd my absolute value bars go, kids?
It's there's x and then there's down the size, right above the ABC.
Right? Oh, yep, duh.
I can never find it.
Thank you. Okay, what was it? Absolute value of what? X minus, was it 5 in there?
Yeah.
Okay, there's x. There's the parent function right there. You guys agree with that?
Yeah.
So minus 5 is going to move it right 5 units. And then there was a minus 4 out there. Is that correct?
Plus 4.
Okay, so that's the function that we started with. That was the original f of x. They want to take everything that's down here and flip it over the x-axis, everything that's up here. So this looks like a V shape. We're going to have an upside down V shape that's reflected. What did we come up with for h of x, kids?
Negative and then absolute value x minus 5. And then that ends and then it's plus 4.
And then plus 4.
Yeah. No, outside of the absolute.
Oops, yep, thank you. Darn technology. Does that look like the green function flipped over to the purple function?
Yeah.
It's kind of like the game yesterday. It was a green function for a long time, and then finally purple function took over at the end of the game. Ties. It's like kissing your sister. Dumb. Who thought ties in pro sports was a good idea? I understand in hockey. I get that. They play 82 games. But in football, when you have 16 games as your record, that's just D-U-M dumb. Right, Keegan? Does that look like a reflection, one flipped over on top of the other?
Yeah.
Are we right?
Yes.
We have to be, okay? We have to be. Right? Let's try another one. It says write a function g whose reflection into what, kids?
Y-axis.
This is the tricky one. Okay? To reflect in the y-axis, it's not negating everything. It doesn't say negate everything. It just says negate inside of what? Inside of parentheses. So let's do this. We're going to have f of x. Maybe I should make the note up here. If I want to reflect in the y-axis right here, here's what this would look like, kids. First of all, our rule for this is f of negative x, right? What this is really saying is then change the sign of your x value. So anybody want to take a shot at writing g of x for me? Anybody want to take a shot?
Would it be absolute value x minus 5 in parentheses 4?
You're pretty close. Anybody want to help or add one little piece of information?
Would it be negative 4?
Not quite. Well, the minus 4 is okay, yes. This is basically saying anywhere where you have an x right here, okay, f of x was equal to this function right here, saying that no matter what this is, so if x was 5, you would plug 5 in here and get a value out. But they're now saying throw in a negative x. So right down here, this x should be what kind of x?
Negative.
Negative x. We're going to put a negative x in here. Okay, so let's see what that does. There should be a negative sign out in front of that. Let's check. Let's see. Do we make some changes inside of parentheses here? Again, absolute value bars are just like parentheses. Did I make some changes inside of parentheses here?
No.
You bet I did. Let's see what this looks like. Let's see if this worked. I'm a little worried about this one. Okay. Okay, so we still have the minus 4 as part of our new function. But I don't want this negative out in front. Where do I want it now, kids? Do I want it in front of the bars or inside of the bars now? Inside the bars here. So let's see what that does. Okay. Ooh, does it look like this flipped over the y-axis there for us? Okay. Now again, this is going to be tricky. It's not going to be the easiest thing in the world to do, but if you can remember, am I working inside of parentheses or outside of parentheses with these rules, I think you'll understand this. Okay? Questions to this point? I'm going to chalk it up to one of three things. A, it's Monday. B, it's first hour. C, it's Monday. First hour. C, it's Monday, first hour. You guys had a fun weekend, it looks like. Yeah? Okay, let's go. Next page here, I think. I'm sorry, example 3. Let's get example 3. How about I volunteer to read example 3 for me?
Let f of x equal x minus 1 plus 2. Write a function g whose graph is a horizontal stretch of the graph of x f by a factor of 5.
Let me get to decimals here and put the original in. So absolute value of x, what's the x part? X plus?
No, in absolute value is x minus 1.
Okay.
And then plus 2 is outside of it.
Plus 2?
Yeah.
Okay, so here's the original function right here, right, kids? All right, let's talk about what we are doing here. We need to come up with a function that is a horizontal what?
Stretch.
By a factor of?
5.
Okay, take a look at the rules for horizontal stretch. Does A have to be more than 1 or A have to be less than 1? Look at your horizontal stretch rules. A value going to be more than 1 or less than 1?
It's going to be less.
Less than 1, okay?
Wait, what'd you say?
So look at your horizontal stretch rules.
Okay.
Is the value we're going to multiply by going to be more than 1 or less than 1 for a stretch?
Less than 1.
Is that going to happen inside the parentheses or outside of the parentheses?
Inside.
Inside the parentheses, right? Okay. so stretching something horizontally means taking it and pulling it outward, both directions, isn't it? Okay. It says stretch this by a factor of what? 5. But you just told me that the A value had to be less than what? 1. How do you stretch it by a factor of 5? I'm sorry, who said that? Put it over 5? 1 over 5. Very good. That's awesome. Let's try that. So Xavier, what are you thinking here? G of x equal, you said 1 over 5. Is this happening inside or outside of parentheses, kids? Inside. So maybe 1/5 x minus 1 plus 2. Let's try that. I'm concerned about this one. So absolute value. 1/5 x. What'd you say, minus 1? Ah! And plus 2, right? Kids, I think we have a problem here. What's the problem? They're kind of uneven. They're not lined up. Okay? When you deal with absolute value functions, notice this right here and notice this right here, kids. Did the vertex match up at all? Okay, here's the trick to this right here. Horizontal stretches and horizontal shrinks are tough. Okay? Because anytime you have a set of parentheses like this up here, what we needed to do was put my x minus 1 part already in parentheses here. Okay? So do this for me. I'll do it for you here. Let's put some parentheses in up here. I'm going to put a parenthesis here. What do you notice, kids? Does the vertex match up with both of these now? Okay, so if you have something on the inside of something already, if you're going to take 1/5 of that x, if you have like x plus 2 inside of parentheses already, you have to take all of that part in there times the 1/5. Okay, so this is kind of a mess. All right, this is kind of a mess right here. So this is what you should have. Does your vertex line up now? Does it look like it's been stretched by a factor of 5? In other words, take a look at this point right here. What's the y value to, well, let's just do this one right here. What's the x value to that point? Looks like 0. I don't like that. I'm going to pick on... Yep, we're good. All good. Stretched by a factor of 5. Yep, it's all good here. It's all good. Do you guys see the stretch? You see the stretch right here? It's like taking this thing and doing what? Yep, so if I pull these points out this way, that's where you end up at, okay? So that's what's happening here, 1/5. All right, so let's look at the next one. Is there a part B to this one?
Yeah.
Next one says, write a function h is a vertical what?
Shrink.
Okay, vertical shrinks are pretty easy. This just goes out front. So you're going to multiply everything that you had originally times what?
0.25.
Okay, so to shrink this, to shrink this right here, you always have your a value times all of f of x. Okay, so what you're going to do is you're going to take this 0.25 times your whole function, f of x here. What was the original function, kids? Absolute value of
X minus 1.
x minus 1,
2. No, put a parenthesis here and x value.
and then plus 2 here. Okay, so we need to, again, what this is saying here for the following is this. If you're going to vertically shrink something right here, you're going to have some value a times the whole function. Isn't the whole function right here in parentheses, kids? So I need to take this whole thing times what value? 0.25. Okay, so let's see if this works here. So I want this 1/5 to be where, kids? Where do I want 1/5 to be?
On the outside.
On the outside. But I also need to make sure I'm taking this whole function with the plus 2 times it. So I'm going to put 1/5 out in front. And then I'm going to go parenthesis here and parenthesis there. Okay. Quick question with absolute values. Do my vertices line up here? Number 1.
Yeah.
Okay. And then take a look at this right here. To shrink this by, oh, this should have been, was it 0.25 out front? I don't know why I put 1/5. It should have been 0.25 out front, right? So let's take a look at, say, how about this point right here? What's the y value to this point? If this is 0, 0 right here, what's the y value to this point right here? 4, what's the y value here? 1. Isn't 1 1/4 of this original function where 4 is at? In other words, if 4 is the y value here, if I multiply that by 1/4, it makes it down to 1. So isn't that vertically shrinking these points or getting them closer to the x-axis here? Okay, so that's what you would do there. Now again, why did I have to put parentheses around all of this, kids? Why did I have to put parentheses around all of this with the 0.25 out front?
Whenever you do a shrink, it has to be inside the parentheses.
Okay, whenever you do a shrink, if you're going to shrink vertically or stretch vertically, you got to have 0.25 times the whole function. And our whole function to start with was this in parentheses, right? Okay, so keep that in mind. Okay, last couple here. This won't take too much longer here, and we'll get you on some stuff here. We're almost done. This class goes fast. All right, how about example 4? Somebody read number 4 for me. We're going to combine some transformations right here. Anybody want this one?
Let the graph of h be a horizontal stretch by a factor of 8 followed by a translation 10 units down of the graph of x, f of x equals x. Write a rule for h.
Okay, so the original function is x, right?
Yeah.
F of x equals x. That's just going to be a line. Okay, so here's the deal. F of x is equal to x. We need to have a horizontal, what's it say? Horizontal stretch of 8. So in parentheses, we're going to have, do I want 8 or something else for a horizontal stretch? Does A have to be more than 1 or less than 1? Think back to what Xavier said earlier. Okay, so we're going to have 1/8 x.
Oh.
So it's like the reciprocal of it. 1/8 x. Where's the division sign? Okay, does that take these points like right here and stretch them further out? In other words, does this point go and stretch horizontally over here somewhere? Did this point right here stretch somewhere else over here? Looks like it. What's the x value to this point right here, kids? -1. Looks like if I follow this horizontal over here, I hit at -8, don't I?
Yeah.
So that works. And then it said take that now and shift it what direction?
10 units down.
Okay, 10 units down outside of parentheses, so minus what?
10.
Minus 10. What's the function we come up with then?
Like,
What do we come up with here? What are you going to write for your function now? It would be 1/8 x minus what?
10.
So your function here is simply let h be that function. Write a rule for h. H would equal 1/8 x minus 10. There it is. Okay. All right, last one here then, guys. It says you make cards to sell. Your revenue is represented by f of x equals what?
3x.
3x. Your profit is $15 more than 60% of the revenue for x cards. What's your profit for 200 cards? What? We could model this with a function. We could graph it. Said your profit. We got to come up with a function. Profit is how much more, kids? Okay, so this is like adding 15, right? It's $15 more than what? 60% of the revenue. Multiplying by 60% is like 0.6 times the function, right? So it's 0.6 times revenue. Guys, what function models revenue here? What function models your revenue? It says your revenue is represented by what? Okay. We're going to come up with a function to represent our profit. I'm going to call our profit P of X. Is that okay? Profit will be P of X. First thing it says to do is $15 more than what first, kids? %60, right? What's 60% as a decimal? What's 60% as a decimal? So it's like taking 0.6 times your revenue function. 60% of the revenue is 0.6 times your revenue function 3x. So it's going to equal 0.6 times 3x. And then how much more than 60% of the revenue, kids? $15 more. Oh my gosh. Okay, now let me make a little room here. What is 0.6 times 3x, kids? What is 0.6 times 3 in other words? What's 6 times 3? 18. Move the decimal back 1.
1.8.
Question becomes, what is your profit for how many cards now? Okay, so you're going to say P of 200 would equal 1.8 times 200 plus 15. Now, I'm not the best at math, but you want me to tell you what that equals?
Yeah.
It's going to equal $375. $375 for profit. Okay. Where'd the 1.8 come from, kids? 0.6 times 3, because that was what percent of my revenue?
60.
And the revenue was defined by what function?
3x.
3x. So 0.6 times the 3x. The 0.6 times the 3x, that is 60% of my revenue, depending on how many cards you sell, plus the $15 more than that value. Okay, that plus 15 on the end. All right? So that function would model that. Okay? Again, tough stuff here. I'm going to send out 2.2 here in a little bit. Won't be doing until Wednesday. Remember, 2.1, what time today?
6.
If I didn't get to practice 2.1 today, first thing tomorrow morning. Make sense? If you have questions on that, win time would be a great thing to sign up for. So you've got about 2 minutes. If you want to get in there and sign up for a win, that would be awesome. Any questions?